Grab your hard hat, rookie, and let's dive right into this explainer. Today, we're mastering the strict cable tray inspection standards required for top-tier industrial sites. I'm going to walk you through exactly what we look for when we step onto a massive project site, pulling directly from the absolute most rigorous inspection checklist out there. We're not just looking at metal channels today, no. We are looking at the absolute backbone of a facility's power and control systems.
A plant is only as safe as its wiring, and wiring is only as safe as its tray. I need you to memorize that mantra right now. It's the golden rule for every veteran inspector out there. Why? Well, because catastrophic maintenance failures, the really bad ones, almost always start with poor tray installation. Before any cable laying activities even kick off, we're out there doing a massive 9-point quality control walkthrough. If the tray fails, the cables fail, and the whole plant goes down. It really is that simple.
Think of this agenda as our clipboard checklist for today's shift briefing before we head out into the field. We're going to systematically hit materials and drawings, installation and supports, clearances and covers, grounding and hardware, workmanship standards, and finally, project documentation. Let's get to work. Section 1. Materials and drawings. This is the baseline of our inspection. Look, our walkthrough doesn't start up in the air. It starts right here on the ground, in the staging area. We have to check all the materials before they ever touch the scaffolding or get hoisted up. I need you to understand from day one that the approved drawing is the law. We are specifically looking at the approved IFC drawings that's issued for construction. We never ever deviate from these. Our very first job is to verify that the cable tray type, the size, the width, the thickness, and the actual material perfectly match what's on these approved drawings and the approved material submittals. There's literally zero room for guesswork here. Because honestly, there's a massive difference between paper approvals and field reality. On paper, you have the submittal, right? It's basically the promise of what we're supposed to get. But out here in the real world, you have to ensure that every single tray, cover, fitting, and support is physically pristine. I'm talking about getting up close and looking for any signs of corrosion, any deformation from shipping, and absolutely no sharp edges. If it doesn't pass this visual test, it gets rejected on the spot before installation even begins. Okay, Section 2, Installation and Supports. We're building the foundation now.
Step back with me for a second. Look at that whole run stretching across the facility. Now let's check the physical installation. The absolute crucial point here is that proper support, perfect alignment, and expansion joints are what keep this entire system from collapsing under some seriously heavy loads. The routing has to match those IFC drawings to the letter. Trays need to be perfectly aligned, level, and securely supported. We can't have any interference with piping, air ducts, or structural steel. Everything has its own designated lane. And you got to think ahead. Is there enough access left for maintenance and future cable pulls? For the supports themselves, spacing has to comply with the approved design and NEMA VE2 requirements. And here's a major red flag we always look for: splice joints. They should never, ever be located directly above the supports. Finally, for those really long runs, we got to verify that expansion joints are actually installed to handle thermal expansion.
Moving on to Section 3, Clearances and Covers. This is all about protecting the core. Let's dive deeper into the run now and check how the tray interacts with its surrounding environment, and specifically, the highly sensitive cables it's going to hold. Mixing cable types or getting too close to hot piping? Yeah, that's a guaranteed disaster. We have very strict minimum clearances to follow. Vertically and horizontally, we absolutely must maintain the required separation gaps between power, control, instrument, and communication lines to prevent electrical interference. For heat and process, we need a safe buffer away from hot surfaces and process piping so we don't end up melting the insulation. And hey, don't forget top clearance. You have to leave enough room above the trays so the maintenance crews can actually get their hands in there down the road.
And environmental protection from the sun and the elements is just as vital as the tray itself. If we're working with outdoor trays, they have to have ventilated covers unless the spec specifically says otherwise. And we don't just throw these covers on. They've got to be properly secured with stainless steel hardware. Oh, and here's a pro tip that catches a ton of rookies out. If you have a vertical outdoor tray, it has to be covered on both sides when required by the standard. Keep that one in your back pocket.
Section 4, Grounding and Hardware, our electrical safety net. Get up close to those joints right now. We are scrutinizing for absolute electrical safety and structural integrity. I'm firing off these requirements pretty fast, but that's because a single missing stainless steel bolt or a loose ground can literally compromise the entire facility. First up, all tray sections must be electrically continuous. That means wherever we have expansion joints or non-continuous sections, we better see bonding jumpers perfectly installed across them. Grounding connections have to be properly tightened and clearly identified. Then we meticulously check the hardware. Do we have the correct bolts, nuts, washers, splice plates, and clamps? Are they tightened to spec? And crucially, are we using stainless steel fasteners in the exact locations where they're specified? You miss just one of these and you've got a major safety violation on your hands.
All right, Section 5, Workmanship Standards. This right here is the golden rule.
Let's hit pause on our physical walkthrough for just a second. I want to focus on the actual mindset of a top-tier inspector. If you want to survive on my site, you need to know the answer to this question before we allow you to pull a single cable. Think about it for a second. What would you say is the #1 cause of future maintenance nightmares in cable tray systems? The answer? Poor workmanship. Plain and simple. Specifically, I'm talking about sharp edges, burrs, and raw cut surfaces or projections. When cables are pulled, or even just as they naturally shift and vibrate over the years, those tiny sharp edges will slowly, inevitably slice right through the cable insulation. That leads to catastrophic shorts. We demand perfection on site. Absolutely no sharp edges or burrs. Any cut surfaces have to be touched up immediately with an approved protective coating to prevent rust and smooth out the edge. The whole installation has to be neat, professionally finished every single time. No exceptions.
Section 6, Project Documentation. The all-important paper trail.
Time to head back to the desk, rookie, because the job isn't done until the paperwork flawlessly matches the field conditions. Let's trace our procedural flow here. We don't just walk away and say, it looks good, we prove it. First, the approved IFC drawings must be physically available right there with us. Then we ensure the material inspection request, the MIR, is fully approved. After that, the actual inspection request, known as the RFI, has to be submitted. Then we rigorously, painstakingly complete all our quality checklists, the ITP, the SITP, and our standard SAIC checklists. Only when every single box is checked, every burr is smoothed, and every support is verified do we give final approval and close out the inspection records for acceptance.
So I'm going to leave you with this final thought today. Really ask yourself, would the cable trays on your current site actually pass this level of extreme scrutiny? Are your supports perfectly compliant? Are those grounds truly continuous? Is your paperwork totally flawless? Take these standards to heart, apply them every single day on site, and never, ever compromise on the drawings or your workmanship. Because remember, that plant is only as safe as its tray.